Subject of today's tutorial are kinetics and thermodynamics at equilibrium reactions. Here we have an instructive example, the azo-coupling with aniline. In the first step, aniline reacts with the nitrosyl cation, preferentially at the amino group. Overall, water is eliminated to give this diazonium salt. We have marked it as compound A. Later on we will meet A again. So the nitrosyl cation, kinetically favored, reacts here because with a free electron pair at the nitrogen we have here the center with the highest negative electron density. Nitrosyl cation might also react in para position, but this is observed when the amino group has, for instance, two additional methyl groups, so with dimethyl aniline. Then temporarily at the free electron pair the nitrosyl group will react, but in equilibrium it will then migrate to the para position for the electrophilic aromatic substitution. So, with the diazonium salt in hand, we then can try the reaction with aniline in order to achieve the formation of the azo-coupling product. However, out of the same reason why the nitrosyl cation preferentially kinetically favored reacts at the amino group, also the diazonium salt will react at this position to give this compound with a chain of 3 nitrogens. If we deprotonate, we get to this triazine. Reprotonating will take place at this position because then we have a nicely conjugated cation, therefore stabilized cation. Now, how can we get to the target product, the azo-coupling product? Well, this is possible because all these reactions are equilibrium reactions. This part is kinetically favored. The target compound is thermodynamically favored product, since here we have a nice donator-acceptor substituted system. So we have equilibrium reactions, and as long as we have some acid as catalyst present, then the retro reaction can take place. We have to wait for a while, maybe heating a little bit up, and then we will finally end up with the azo-coupling process. We need at least catalytic amounts of a proton source, for instance HCl, but not too much. If we have a large excess of acid, then the aniline will be completely protonated, and with an ammonium salt no electrophilic substitution will take place at this ring anymore. Thanks for listening.